Hello friends, in today's class we are going to solve problem related with threads. Welcome here and let's start problem solving using threads. So this is the statement. Consider the following statement with respect to the user level threads and kernel supported threads. So statements are: context switch is faster with kernel supported thread, which is which of the above statements are true? Okay, we have to comment about the true, and the statements are: context switch is faster with kernel supported thread, which is a false statement. Okay, user supported threads are faster because they required less intervention from this kernel, and there is no switching required from user mode to kernel mode. For user level thread, a system call can block the entire process. This is true because this user level threads are transparent to kernel. They don't see them as a separate process, but as a single process, and it can block the entire process. Kernel supported thread can be scheduled independently, and this is again a true statement. User level threads are transparent to kernel, and this is also a true statement. So 2, 3 and 4 are true, and that goes with your option A, that 2, 3 and 4 is a true statement. Okay, so answer is A here. 2004, the next question is: which one of the following is not shared by the thread of the same process? Stack, address space, file descriptor table, and message queue. So I have already told you about this address space and this file that is required to be shared. Message queue I haven't told you, but still I told you about they have separate stack and the register files, as you can see over here in this diagram, that each thread is having their separate stack and register files. Okay, so here they don't share the stack because they are treated as a lightweight process. Okay, so this is not shared, and answer is A. The next question is from 2007, and it says that consider the following statements about user level threads and the kernel level threads, and which of the following statement is false? Context switch time is longer for the kernel level thread than for the user level threads. This statement is true. User level threads are faster. Just before this question, I told you that there is no need of switching the state from the user mode to kernel mode, and that will definitely take some time. User level threads do not need any hardware support. This is also a true statement. They are managed by there is no mode bit, right? We don't require this mode bit to be present, and mode bit is what? 0 for the user, and or maybe I don't remember exactly, but there is a bit, hardware bit, which is set to 0 or 1, represent a user mode, represent a user mode, or represent what? Represent kernel mode, right? So there is a hardware support required, but in the user level threads we do everything in the user space. So the statement is again true. Related kernel level thread can be scheduled different processors of a multi-processor system, and if you recall the user level threads disadvantage, right? So multi-threaded application in user level thread cannot be used in multi-processing for their advantage. So that was the disadvantage associated here. So each statement is important, and here this statement is again a true statement. Blocking one kernel level thread will block all other related threads. So that is not true for the kernel level threads. Kernel treat them separately. So the statement is false. And that goes with option D, that this answer for this particular question is D. A thread is usually designed, 2011 question, a thread is usually designed as a lightweight process because an operating system maintains a smaller data structure for a thread than a process, right? Smaller data structure. In relation to this, which of the following is true? On per thread basis, OS maintains CPU register state only. The problem is not with CPU register. When you claim that only, what about the stack, right? So it also maintains the stack. So I'll go with this statement. Because of this just simple term only, I'll say this one as false. The OS do not maintain a separate stack for each thread. Does not maintain. And yes, it maintains. So that statement also goes with a false statement. On per thread basis, OS does not maintain virtual memory state. On per thread basis, this does not maintain a virtual memory state. Yes, it does maintain, because it is a false statement, because okay, we have to find out the true statement. On per thread basis, OS does not maintain, but on per thread basis, OS does not maintain virtual. So memory part is shared actually. Okay, virtual memory part. Okay, virtual memory part is a part where a code will be assigned. So memory allocation they share. Okay, that is one of the advantages. And here it is saying that it does not maintain on per thread basis, OS does not maintain virtual memory state, right? So that goes with the statement seems to be true actually. Yes, it does not maintain per thread basis, for they share it. On per thread basis, OS maintains only scheduling and accounting information. Okay, so again this statement, because of the term per thread basis, only scheduling and accounting information, that goes with the false statement. And we can say that answer in this case is C, that it does not maintain a virtual memory state. Okay, so 2007, maybe one of the question is from one of the paper which is IT. Which one is which, I don't know, but 2007 we don't have two questions. We have one question stressing only one topic. Okay, I think we have done this, right? We have just now done this. It's repeating actually. We have just done the, yes, we have done this question. Okay, repetition. Okay. Let the time taken to switch between the user and the kernel mode of execution be T1, while the time taken to switch between the two processes be T2. Which of the following is true? Okay, so between switching between the user mode and kernel mode, user mode and kernel mode, right, and switching between two processes, switching between two processes. Now when you are switching between two processes, you required to make this transition from user mode to kernel mode. User mode to kernel mode, you can say that the time T1 will be included in time of T2. Okay, the user mode to kernel mode, it is required to shift from user mode to kernel mode when you are switching between the two processes. Okay, so there are some schedulers are there that will do this thing, and there is a short-term schedulers, right? There is a short-term schedulers, and there is also dispatcher. So that between the process requires intervention from the kernel or operating system. And yes, you have to go to the kernel mode for executing the short-term schedulers, right? So definitely T1, the time for switching between the modes will be definitely smaller than the time between the switching between the processes. Okay, 2014 question, and we need to comment about false. So as you can observe here that there is a quite few numbers of questions are there from this theoretical topic, that is thread. Okay, so the question is which of the following is false, and user level threads are not scheduled by kernel, right? So user level threads are not scheduled by the kernel. Let's see the more statement. When a user level thread is blocked, all other thread of its process is blocked. The statement is true. Context switching between user level thread is faster than the context switching between kernel level threads. This is also true. Kernel level threads cannot share the code segment, and this statement is false. Okay, user level threads are not scheduled by the kernel. Okay, now this state, then user level threads are, kernel don't see them. Right now here this topic, there is a thread library. Okay, there is a thread library provides APIs for creating and managing the threads. Okay, so this is the, there is a, for each thread library is responsible for this managing this particular threads, and they are not scheduled. Yes, they are not scheduled by the they are not scheduled by the kernel. So this statement is also goes with true statement. Okay, so that goes with here as option D, that kernel level thread cannot share the code segment. That is a false statement. Thread of a process share. So what they share actually? So they share global variable but not the heap but not the global variable, neither global variable not the heap, both heap and the global variable, right? So we know that there is a stack, heap, and data and code section, right? Only they don't have their share is the register. Okay, register they don't share with them, and the stack content they don't share with them. Apart from that, they share everything. So we can say both heap and global variable. Okay, both heap is a part of memory and global variable is part of your data, so they share this both the entity. Set 2 2017, that which of the following is shared by all the threads in the process. Okay, so what they share? So they share program counter, stack and register they don't share, but they share program counter and address space, and with goes with 1 and okay, program counter, because they are running program counter is part of what? It's a part of their register. So what they don't share is shared by all the threads. So the shared by all the thread will be in this case will be shared by all the thread will be in this case is address space. Only here program counter they don't share. It is a part of the register and they are executed independently. Stack we know that this, okay, but program counter also they don't share. So we'll go with this 3 in that address space. Okay, 3 is the answer. B is the answer for this. Okay, so now we are done with this entire discussion of this. The only place I think that you might confusing here in this is user level threads are not scheduled by kernel. Okay, now the statement is true. They are managed by API, and there is a thread library is there. Okay, so it is not it is transparent. Okay, it will not do anything, but it is the thread library that do the scheduling of this kernel user level thread. Okay, so that's all for this discussion. I hope you agree with this problem solving. Okay, so that's all. Thank you.